What up, your boy C. Rizzy coming at you with Unit 8, Lesson 3, Trigonometry. Our essential question, how do you find a side length or angle measure in a right triangle? And our objective is to use sine, cosine, and tangent ratios to determine side lengths and angle measures in a right triangle. Our essential understanding is that if you know certain combinations of side lengths and angle measures of a right triangle, you can use ratios, trigonometric ratios, to find other side lengths and angle measures. Okay, so I tried to change it up from the book because I didn't like the way they explained it, and I think this is going to be a little bit easier. So the first thing we need to learn is this symbol right here. This symbol is a Greek symbol called theta. And theta represents the angle that you're using in your trig ratio. So it's the angle used in trig ratio. Okay, so you'll figure out later what I'm kind of talking about. But in a right triangle, you have three angles. The right angle and the other two angles. Theta is never the right angle. Theta is always one of the other two angles. So in these two triangles, theta could either be x or theta could be z. What's important here to note, though, is in your ratios, you need to know what your sides are called. Okay? In a right triangle, the side C in all these triangles is always the hypotenuse. The side across from the right angle is always the hypotenuse. What does change, though, depending on what theta is, or what theta is defined as, are the legs. Okay, in the first triangle, the side A is called the adjacent. It's adjacent because it's right next to theta. Now, the hypotenuse is right next to theta also, but we've already defined that as the hypotenuse. So the other side next to theta has to be the adjacent side. So if you look in the second triangle again, you'll see A is next to angle Z, or theta. C is the hypotenuse, so A has to be the adjacent side. And then B, if you guessed it, is called the opposite side. Okay, and again, the side changes depending on where theta is. The opposite side is always across from theta. Okay, so what are these ratios and what do they look like? So this is what you have to have memorized. SOHCAHTOA. This little thing teaches you exactly how to do the trig ratios. Okay? So the first one we start with is SO, which stands for sine. So sine times theta is equal to O, which stands for opposite, divided by H, which stands for hypotenuse. So sine theta is equal to opposite over hypotenuse. Okay, and I know we use the three letters SIN, but that's just because how it looks like in a calculator. CA, which is going to be the cosine, we're going to use cosine, and we abbreviate that COS. Cosine of theta is equal to A, which stands for adjacent, divided by H, which again stands for hypotenuse. And then the last one, TOA, which is T for tangent, which we abbreviate TAN, tan theta is equal to, and again, O is still opposite, and A stands for adjacent. Okay, so I gave you a little cheat sheet down here in the corner. The question here is, what are sine, cosine, and tangent ratios for angle T? Now, what determines opposite, adjacent, and hypotenuse, from what I said earlier, depends on which angle represents theta. In this problem, they told us angle T, so theta is going to be angle T. So now I can figure out which sides are what depending on where theta is. Hypotenuse never changes. But now, which side is next to theta? That's going to be the 15. So that's going to be the adjacent side. And then which side is across from theta? The 8. That's obviously going to be my opposite side. So all they want me to do is just fill in the trig ratio. So sine of theta is equal to opposite, which is 8, over hypotenuse, which is 17. Cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over the adjacent side. So those are just the ratios. I haven't solved for anything yet, but those are just the ratios. That way you know how to solve for them. Okay, so now how does this change if my theta was now at angle G? 17 is still the hypotenuse. But now, because theta is up here, the 8 is now the adjacent side, and the 15 now becomes the opposite side. So now I rewrite these, and now sine of theta, which was before 8 over 15, or 8 over 17, is now 15 over 17. Cosine of theta is now 8 over 17. And tangent of theta is now equal to opposite 15 over adjacent 8. All right, I'm going to stop it here because I want to teach you how to solve it next, but this is going to have to be a 2-part video. So have these notes. See you in part 2.